Why, hello. This phone call could be worth $1 million.
Excuse me, but it's probably not worth that.
Well, you never know. Maybe you won the lottery. A real estate deal.
All right, here we go. Let's take a look at
everything,
6.2,
number two.
proving triangles similar. Starting off with a little shout out to Austin Powers there. Dr. Evil and Mini-Me. So this is about proving triangles are similar. Yes, they look the same. Same shape, different size. One is bigger than the other one. But are they really similar? So we're going to spend this section proving it. And let's get rolling on that. Here we go. So are these similar? So they look like it, but we can't just go by looks. We need some information. And I know everybody loves proofs. I see you guys looking at that word proving. You're getting excited. Oh, do I get to do a two-column proof? The statement reason thing. We'll see. We'll see what happens. So let's just mark this. Given that C is congruent to D, so if I have C is congruent to D, and I have A is congruent to O, so let's mark our picture. Are they similar? Well, if you remember back to chapter unit 4 when we talked about proving triangles congruent, what was one of our things that didn't work? Remember this? Angle, angle, angle. It didn't necessarily mean congruent. It meant that it was similar. So if these two are the same, let's make up numbers. If that's 100 and that one's 40, what has to be left over here? If this is 100, this is 40, well, this has to be 40. Because it has to add up to 180. So if this is 100 and this is 40, what has to be left over? Again, it has to be 40 because it has 180. So really, we know if two angles are congruent, actually all three are. So if you think about it for a while, it makes sense. If two of them we know are congruent, then the last one has to also be congruent. So technically, this is angle, 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 which just means that they're similar. So yes, this does prove it. If you can show angle, 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 yes, it means a congruent. I'm sorry, whoa. It means it's similar. Doesn't mean they're congruent. So same shape, different size. So that's our first little, it's actually a postulate, and we don't have to do the third A there. We can just do angle, angle. And the way we do this is we say angle, angle, similarity postulate. So you need this symbol here. I know we did a lot of SAS, SSS, all those. This is angle, angle, similarity. So let's fill in this postulate. If two angles of one triangle are congruent to two angles of another triangle, then what? Then the triangles are similar. Awesome. And I hope your handwriting looks better than mine, but they are similar. Excellent. So let's draw a little picture of this, make sure we get a nice picture. So if I take, this, and I want one that's just like that. So if we do cat and dog, I like that example. So if they give you two of these, just like our warm-up right there, like our first little picture, if they say C is congruent to D, A is congruent to O, that's all you need. We have angle, angle, similarity. So that is the symbol right there. Boom, done. There it is. That proves it. What has to be true, but you have to name this correctly. So if you want to call it, cat seems too easy. What if I call it, we'll do a cat. It's tough because it spells a word. Triangle cat is similar to what? Order is very important. You have to go from C to A to T, so this must match. See how C matches D, A matches O, and T matches G. So this actually is cat to dog. So it actually has to match up with the one it's congruent to. Then we know that they're similar. Notice it's a similar sign, not congruent. Fantastic. Moving on. We have two more of these. Notice this. We had this before, didn't we? Side, angle, side. Same kind of thing, but this is, not that. This is side, angle, side, similarity. So how does this one work? If an angle of one triangle is congruent to an angle of a second triangle and the sides that include the two angles are proportional, wow, it's a mouthful, then what? Then the triangles are similar. So really it's side, angle, side again, but we got to go beyond just marking it. So like it tells me O and A are congruent. So O and A are congruent. So now we're looking at, the sides right around it, side, angle, side again. But I'm not looking for congruent like this. I don't want congruent. I want proportional. There's no way they're going to be congruent. If they were congruent, they'd be congruent triangles. I'm looking at, are they proportional? So like, is the ratio of B over A, like if this is 2 and MA would be what, 4? What else am I looking at? I'm looking at this ratio, OY. Is this one proportional to this one? So is OY the same as A to the N? So that's what I'm looking for. If that's true, then we can say triangle, and I did a word again. From B to O to Y, we have to make sure it's similar to what? M to A to N. So I know I'm spelling words here, but make sure it matches up perfectly. So this ratio must be the same. So like 2 is to 4 must equal the ratio of this. Must be the same ratio. Let's put up in a full-size example here. So check this one out. I kind of tweaked it a little bit here, but the same boy and man. If angle B is congruent to angle M. So pause it, draw it, make sure you have this. That's good. So I'm looking at side angle side here. So I'm looking for side angle side similarity is my goal. I got to show the proportional. So is 4 is to 8. Is that the same thing as is this side is to this side? As what? This side is to this side. So we've still got our side angle side. Is 3 to 6, and you got to go little, be consistent. Little is to big or big is little. So consistent. Yeah, what is 4/8? That's just 1/2. What is 3/6? That's 1/2. So yes, I do have side angle side similarity. So we're going to check this. We're actually going to prove these and crunch these numbers. So if you prove the proportion is the same, you're good to go. Fantastic. Last one. There's only 3 of these, so that's fantastic. That's good for us. Last one is the side postulate. Boom, there it is. So we can kind of fill this in. If 2 angles, I think this is wrong. If 2 angles of one triangle are, so if the corresponding sides of 2 triangles are proportional, so if all the sides are proportional, what does that mean? Then we can say, I bet you guessed it, the triangles are similar. So these are shortcuts to show similarity. So that's all. Just like we had shortcuts to show congruence, these are shortcuts to show similarity. Instead of saying all the angles are the same, all the sides are proportional, we can do a little shortcut here. So let's take a look at this. If EA is proportional to LO, then what else has to happen? We've got AR is proportional to OB, and we were doing this all last section. So what's left? This one has to be proportional to this, so ER has to be proportional to LB. Fantastic. So we know they have to be proportional. They have to have that same scale factor for all 3 of them. It has to be, this one has to be half the size of the big one or something like that. And again, be careful with how you name these. We're looking at, I'm going to name this. It looks like I was going for earlobe here, even though it's earlob. Good one, Mr. Breast. I'm going to change it to, just to mix it up a little bit, to ARE. That's still a word, but it's similar to what? So you got to be consistent. A matches O, so we got O. B matches R and L. So you have to make sure naming it goes in the right order. Fantastic. Moving on, let's see an example of this. So here is side similarity. We have to show it. So you actually have to show, match them up. This side is to this side. So 15 is to 5 is the same thing as saying this side is to this side. So it's proportional to 39 over 13, which then is proportional to the bottom side, has to match. If it's similar, that has to equal 36 over 12. Does that work? Are they all the same scale factor? Sure. What is 15 divided by 5? It's 3. What is 39 divided by 13? It's 3. What is 36 divided by 12? It's 3. And you can do it the other way. You can do big to small and get 1/3, 1/3, 1/3. That's cool too, but you got to show them all. If you want to use side, you need all 3 of them. So you got to match them up. I made these work out friendly, but don't freak out if you get decimals. As long as the decimal is the same, you are good to go. Fantastic. One more little slide here. Let's do some problems with this. So these can kind of be tricky. So I've got this mess. I want to prove, first of all, are these similar? Maybe. They look like they could be. I got to prove it. So not all of these are going to be similar. So what's it looking like here? Vertical angles, let's mark it. So I've got vertical angles. And what is this? I've got, it looks like this side matches which side over here. So can we see the order here? It's kind of tricky. I think this is just, it looks like this side matches this side. And this, let me use a different color over here. This side matches this side. Fantastic. So it's kind of weird which one matches which one, but it looks like this is the shorter of the 2, so you have to use the shorter. So 15 is smaller than 8. That's how I knew. 15 is smaller than 18, so 50 is smaller than 60, so I knew they had to match up. So if I'm going to do side angle side, I know the angle's good. Is 15 over 50 the same thing as what? Let me use the blue marker. Is it 18 over 60? Are they the same? Ooh, we may get some decimals here. Does this work out? Let's try it. What is 15 divided by 50? It's 0.3. What is 18 divided by 60? So I divide them both out. Boom! They're both 0.3. So what does that mean? Oops, we can't even see my screen here. Let's shrink that down a little bit. There it is. So they're both 0.3. So yes, they're both 0.3. So yes, this is similar. So I'm going to say these are similar by what? They're similar by side, angle, side, similarity. And now name the triangle. So again, let's be careful. W. Oh, it's the middle. I was like, where's W? Right here in the middle. W is going to match W. Then they went to V. So if I go to V, I have to go to M. W, M. And then what's the last one? Got to be N. So make sure you name it correctly. Fantastic. So yes, this is a big fat yes. They are similar. Woohoo! Move to the next one right here. We got this laid up. And if I look at it, I'm given what? No angles, but I'm given all the sides. So really I'm checking side, side, side similarity. That's my goal. Is it side, side, side similarity? Let's check it out. If it is, they're all proportional. So let's start with the smallest. Here's the small side is 8. What's the small side over here? 48. And luckily they didn't do any flips. That first one was tricky. The next small side is 9. What's the next smallest side? Oh wait, they did flip. No. Wow, that's tricky. They did flip. This is the middle side. Look at this. This is the middle side. I would not have caught that. Woohoo! Lucked out there. So always double check it. Even if it looks like it. Longest side, longest side. So match them up. Shortest, medium, longest. Now we can set them up and see if they work. So is 8 over 48 the same thing as, do your reds, 9 is to 59? And is it the same thing as 10 is to 60? Do these all match up? Let's find out. So I'm going to clear this out, see what we get. 8 divided by 48. Boom. 0.16666 repeating forever. Is that the same thing as 9 divided by 59? No, I'm done right there. They are not the same. And if you want to go farther, feel free, but I'm done. You can be done right there. This one's not going to work out either. Well, that was the same as the middle one. So let's bring that in here just so we have some proof, because this is about proving triangles. So here's my proof right here. These do not match up. Check that out. So this middle one is off. So actually, you know, we have it except for this guy right here. He does not have it. So this doesn't work. So this is a no. No, they're not similar. Don't even write it. They're not similar to each other. Close, but not enough. Excellent. 2 more of these. I like these. These are kind of fun. So we got overlapping triangles here. Don't freak out. Let's go small side again. So if we look at this, here's the small side, 24, the little triangle. Remember, then it goes to the big triangle. So it's just that right there. So actually, these aren't bad. They've been easier than those two. Those two, I was trying to trick you. 36 is this. Is that the biggest side? I went to the biggest side, and it's going to match this one over here. And now we got to be careful. We have to say, what is this? If this is 81 right here and 36, you have to add them together. So 36 and 81 is 117. Is that total? They did that one for us, but not this one. And then the last one, we've got this side over here is 32. So that's actually my middle is to 104. So yes, it matches up. Small, medium, large, small, medium, large. So again, I'm looking at a side, side, side here. Potential side, side, side similarity coming at you. Does it work? Let's set it up. So my small side was 24 is to 78. My medium side was 32, and it's weird. It's this one right here. I hope you can see that's that one. 32 is to 104. And then again, it has to match them all. So 36 must match 117. So I'm going to go to the calculator again, clear the last one out. So we've got 24 divided by 78. Ooh, that's a crazy decimal. Are we going to get it again? Is it the same thing as 32 over 104? Woohoo, we got 2. Can we get 3? Got to get them all. 36 divided by 117. I feel like I'm on a game show or something. And survey says, yes, it's exactly the same. So boom, there it is. Got this right here. They are all the same. So this is definitely side, side, side. Why? And then let's just go back and name it. So side, side, side. We are going to name this triangle what? Q. So it's going to start at Q again. Q to R is this one. So Q to R means it's Q to D. And then down to S, this brought me down to C. So make sure you name it correctly. That would be how you name it there. One more of these, the finale. Excellent. I like this one right here. I can tell just right off the bat I got vertical angles. Vertical angles are congruent. Now check this out. I've got 89 and 89. So these angles are congruent. So what do I have right here? Boom, I'm looking at angle similarity. You're actually done. I don't have to check any proportions, anything else. If I've got two angles are congruent, these things are similar. That's my favorite. Least amount of work. It's just you're done. Look at all that work I had to do over here. Nothing over here. AA, they're similar, so just make sure you name it correctly. LMN, so I want to go from L to where it went to the second. It went M and E are congruent, so I got to go here, and I'm good to go. Fantastic. Last slide right here. So this is all about proving triangles. What do I got right here? This is a snack pack of pudding. This is pudding. What's in the pudding down there? What is that? Oh, it's a proof. It is a proof. The proof is in the pudding. There it is. So you're probably wondering, can I do one of these two-column proofs? Yes, you can. You can do these all day long, formalize it, and we are going to do that as our application this time. So some people can just do it. If you were good at Unit 4, cruise through them. You'll see them on the test, not the mastery checks. If you need some help, check out the application walkthrough. So these will be on our application portion. If you want to see me formalize it, go watch the application walkthrough. Proof is in the pudding. I'm going to end you with a little clip on that, which I think is hilarity. I don't know if you'll think it's as funny as I do, but I giggled for quite a long time. Good luck on the packet and the mastery check. Peace out.
And he say, "Hey, the proof is in the pudding." And then he run down. The proof is in the pudding? What is this? A cooking show or what? Number one, don't put your proof in the pudding. Alright? If you have a nice proof, mathematical equations and watch out, it is the new theory of relativity. You want to put it in pudding, Einstein? Yeah, make a guess of what happened in probably 3 minutes. Yeah, your proof is now inside the pudding, and the pudding has taken all of the inks away. You come out, you take your paper. If it is vanilla pudding, it is now yellow. Yellow's paper with just smoochy stuff. Good luck show that equation to Good Will Hunting. Proof is in the pudding. Just put the proof on a table.